Good morning, class. Welcome to Mathematics Grade 11 at 9 o'clock on the 30th of April. Today is our last class for the week as we prepare for another long weekend. Happy to have you here with me. Just a reminder, I am Miss Shabalala. You guys can get a hold of me on Twitter at _Mbaliti. And this is another class that we have on trigonometry. For those of you who are first timers, welcome to the class. I'd like to have more interaction with you guys. I'm hoping you guys could respond. We have questions, we have errors, we have steps that I get wrong. So I'm hoping that you guys can respond, talk to me, interact with me, and make this class as feasible for you as possible. Okay. So bear with me, please, to the guys who are used to this. For the newbies, we have rules of engagement that we use in this class. Our rules are quite simple. Number one, respect each other because we're all here to learn. Number two, there's no such thing as a dumb question, so please feel free and comfortable to ask away. Number three, please raise your hand and you will be unmuted when you can ask your question. Number four, please keep your cameras and videos off. Right. 5, please type your question in the chat if you are shy to raise your hand, and I will sure get to answer you as well. Next, we do not tolerate vulgarity. We do respect each other. Next, please don't take the opportunity to learn away from somebody else. Please don't disturb anybody. Please don't disturb the class or the peace in the class. And lastly, please extend the link to your friends for them to join in as well. Right, guys, if you've been following my classes, you will know that I had said to you that we are currently on the last subtopic in trigonometry. Okay, we are currently doing area rule, sine rule, and the cosine rule. And I said to you, the purpose of today's class will only be to take care of the homework questions that I had given to you guys yesterday. Right? I had split up the questions accordingly as the area rule questions, the sine rule questions, and the cosine rule questions. We will spend the first half of next week going through general, all across the board trigonometry questions, because when you do write an exam, there is no heading that's going to, I'd say to you that now you are applying the area rule, that now you are applying the quadratic equations. You're just going to get a trigonometry section in your paper 2, and you need to be able to know what fits in where. So that is the plan for next week. But getting back to today, as I had said, the purpose of today's class is to get on with the homework questions, to build and stabilize and basically solidify the understanding and the use of the 3 rules, the area rule, the sine rule, and the cosine rule. And I'm hoping that as we prepare to move on next week, then with our revision, everyone is then on the same page in terms of what we need to move forward. But first things first, I'd like to do a quick recap of the rules accordingly. First, we have our area rule. Our area rule simply says in any given triangle of ABC, our area of the triangle where you do not have a perpendicular height is half of A times B times sine C. It could be half of A times C times sine B, and it could be half of B times C times sine A. And that you slot in whatever information you have available, and that is how you get your area of a triangle that is not a 90-degree triangle. Right? Next up, we have the sine rule. The sine rule also just simply says sine of A over A is the same as sine of B over B is equal to sine of C over C. When we say this, I wish to reiterate again, we are referring to the ratio relationship between the sides. It does not mean that A, B, C, and D are all one. No. It means that from a ratio perspective, the sine A over A will give you the same ratio as the sine of B over B. Right? And lastly, our cosine rule. Our cosine rule says in any given triangle, a squared is equal to b squared plus c squared minus 2bc cos a, right? You could be using a cosine rule to find angle. You could be using the cosine rule to find a side. So for you to know as well which rule you apply, you look at what you've been given and you look at what you're being asked, right? A lot of the time, the ask is quite simply, in the case of the area rule, you're being asked for an area, right? The possibility is that you might not have the included angle that you should use, but you will be given enough information to find that included angle, in which case you calculate your included angle and you calculate your area. In the sine rule, we could be asking you for a side, we could be asking you for an angle. It depends, again, what information you have been given. The same applies for the cosine rule. So with all these rules, you could get to basically solve an entire triangle. You could get to solve everything that you need for a triangle, all the sides, all the angles. Your starting point is to look at what you have available and which rule allows you to use what. Which brings me to my next slide. I've just done a quick recap where we are going to go through where does each rule apply, under what circumstances does each of the rules apply, okay? So I actually just mentioned the first one when I said there's no 90-degree angle, there's no perpendicular height. Do you guys know which rule has that? Which rule requires that there be no perpendicular heights? Any takers? Anybody want to actually, does anyone want to fill in the first two rows of this table with me? Any takers? Guys, okay, in the interest of time, I'll say to you, it's the area rule that requires that no 90-degree angle must be present. But if you were in class yesterday, you also remember that I had said to you, the same rule applies across the board. The reason why we have these rules is because with all the other triangles, we can simply apply Pythagoras, we can apply all the trig that we've been doing to date. But the moment you don't have a right angle triangle, be it in isosceles or whatnot, you can also apply, you also look for the fact that you don't have a right angle to apply your sine rule and your cosine rule, right? Does anybody remember which rule requires you to have three sides? So when I'm saying that, what I mean is, which formula can you solve for? Remember in the previous slide, I said to you guys, look at what you have so that you know which rule to apply. When you have three sides, which rule can you apply? Does anybody remember from yesterday's class? You can apply the cosine rule from yesterday's class. That's what you can apply when you have three sides, right? Then when you have two sides and one angle, and I reiterate, it is not an included angle, which rule can we apply? It is the sine rule, guys, right? And when we have two angles and one side, which rule are we able to apply? We are able to apply the sine rule, guys. And lastly, when we have two sides and an included angle, which rules are applicable when we have two sides and an included angle? It's both the area rule and the cosine rule. Those are the two rules that we are able to apply when we have an included angle and two sides, right? So from here on out, guys, for the rest of the lesson, I will be going through the homework questions that we were meant to prepare for today. I'm going to take it step by step, but as I go on, because of the monotony of how things work, I'm going to begin to pick up pace. Please stop me if I'm moving too fast. Please slow me down if you see something that doesn't make sense, or please ask your questions if there's anything you need to ask. Always remember, in case we have a minor lag because of network or whatever issues, I need you guys to please reference your questions when you are asking. Right? So our first set of questions was around the area rule yesterday, right? And so I've already prepared the solution, so I'm not going to show you the slide of how the questions looked yesterday. But our first set of questions, we had a question 1, and it had an A and a B, right? Question 1 said, draw a sketch and calculate the area of triangle PQR given the following, right? Question A gave us that Q is 30 degrees, that little r is 10 centimeters, little p is 7 centimeters, right? So let's draw that, and so that we can calculate. Oh, it is good enough. Let's draw that so we can calculate. So guys, there's no specific way to draw your triangle. All you know about your triangle is that it doesn't have a 90-degree angle, right? So we can literally make this PQR, okay? And what we do know, what information do we have? We have that angle Q is 30 degrees. We have that little r, this side, little r is 10 centimeters. And we have little p being 7 centimeters, right? So you can already see we have two sides and an included angle. So we are good to go on our calculation of area. Oh, now I just messed up, right? So the area of triangle PQR is quite simply half of PR times the sine of Q. Hope you guys all agree with me with that. And how do we, so then we'll substitute our P, we'll substitute our R, and we'll substitute our Q into the equation simply like that. And we come out with an area of 17.5 square centimeters. Everybody happy with that answer? Did everybody get that answer? Are there any questions on that answer? Right, so we have our part B to question 1, where we have the triangle PQR again. We'll just draw any old triangle, okay? And we'll call our triangle PQR again. Guys, as you can imagine, I'm not the most creative person, so all my triangles will probably just look the same the whole time, okay? So what do we have? We have angle R, this angle over here. We have that as 110 degrees, okay? We have side Q, the side Q is directly opposite the angle Q. So this is side Q and it's 9 centimeters. We have side P, which is opposite angle P, and that is 8 centimeters. So as you can see again, we have ourselves two sides and an included angle. Again, simply apply our area rule. Half of PQ sine R this time around. We've swapped, let's call it our angles and sides around depending on what we are given, but the formula is actually the same. We solve for that accordingly, and we come up with an area of 33.8 square centimeters. Everybody happy with that? If anyone has any questions, this is question 1 of the area rule questions, and there's A and B. Right? I'll take it that everyone is good and well with the understanding of this, and so I'll move on to question 2. Right? There was question 2 and question 3. I've put them on one slide, right? Question 2 says, find the area of triangle XYZ, given that XZ is 52, XY is 29, and angle X is 58.9 degrees. So no way did they say, please draw this, right? But for yourself, guys, if it'll in any way make things easier for you, if it'll in any way save you time, then you draw the triangles yourself, okay? X, Y, and Z. Okay, so so it's saying XZ, this is XZ, is 52. It's 52. XY is 29. 29. And it's saying that angle X is 58.9. This in here is angle X. 58.9 degrees. Again, we've been given what we need in two sides and an included angle. Okay, guys? So from here, some of us would like to call this side small x, call this side small y, and call this side small z. That is also okay. You're allowed to do that. But because the question didn't give me that option and I wanted to bring the principle across to you guys, I've literally just left it as it's the half of xz times xy times sine of x, right? Substituted the relevant angle and sides, and I came up with an area for triangle XYZ of 645.6 square centimeters, right? Always best to draw, guys, if you can't envision, but I do think that with practice, you get to just seeing it in your head, right? And I will say that a lot of the time, you'll never get a question in isolation on a triangle that requires an angle. A lot of the time, you have the triangle given in the paper. It just is a triangle that we use for a lot of things in trig, and you have to be able to identify if it's a parted triangle, which piece of the triangle you're using for what. But I'm sure you saw in the homework, we have one such example. We have given you the triangle. It's a parted triangle, and you use different triangles to find different things within that one triangle. Okay, next up we have our parallelogram, right? Parallelogram, if we all remember from our area rules and functions, a parallelogram looks like this. You have two sides that are parallel, and you have two sides that are parallel. So this is what a parallelogram looks like. As my parallelograms clearly had a bit of a stroke, but this is what a parallelogram looks like. And it's saying to us here, two adjacent sides are 10 centimeters. So our smaller sides are 10 centimeters, right? And 13 centimeters respectively, right? And we have our 13 centimeters right there. And it says the angle between them, so an adjacent angle, 13 adjacent side, 13 is adjacent to 10, as is 10 adjacent to 13, vice versa. And it's saying that the angle between them is 55 degrees. So it's saying that this angle over here is 55 degrees. All right, guys, I won't go into detail about the qualities or the properties of a parallelogram. I trust that you also know from that this is also 55 degrees. Okay. So from here, what did I do to get the area of this thing? You easily know or recognize that you can split this into two triangles, and they become two exactly identical triangles. So you can calculate the area of one triangle and multiply it by 2, and that will give you the full area of the parallelogram. I hope everybody understands what that means. Hope everybody attended it that way, right? So let's go. So I've simply said then, in this particular case, the area of our parallelogram is 2 times a triangle. So if this is a triangle, I have my half of one side times the other side times the sine of my included angle. Simply. And I've made it 2 because they are 2 triangles, right? And the 2 and the half cancel each other out just like that. And when we calculate for 10 times 13 times sine of 55, we come out with an area of 106.5 square centimeters. Everybody happy with that? Any questions on that? Any issues on that? No, sounds like everyone is okay. Sounds like everybody's good. So I'm going to then move on to question 4, right? Question 4. This was the last question in our area rule section of the homework. In question 4, we are saying, if the area of triangle ABC is 5,000 square meters. So again, let's quickly draw our triangle. A, B, C, right? We can call this little a, call this little b, call this little c. If the area of triangle ABC is 5,000 square meters, with little a being 150 meters, right? With little b being 70 meters. It says, what are the 2 possible sizes of C? Was anybody able to tackle this question for me? Is there anybody who's willing to assist me to go through this one? Did anyone struggle with this one? No takers? Okay. So guys, with this one, we were simply being asked to look for the 2 possibilities for the included angle. Oh, Mbali says you struggled. Okay, Mbali, I'm going to take you through step by step. It gets, when you get the grip, it gets basic, but it's not even that hard. Thank you for your response, Mbali. And I myself had quite a moment when they had said 2 possible sizes. And I said I could get one. Why do I need the other? But actually, soon enough, I came back to my senses. But it's quite basic. So please join me in this. And when I'm done, please tell me, Mbali, if you're good, if you understand, if it's gotten clear for you. Okay? So this question is asking simply, what could this angle possibly be? And it's saying there are 2 possibilities for this angle, right? So we do our usual calculation of an area of a triangle, right? But this time, when we substitute, we have, oh, let me not use BH. Let me use the correct numbers. Right. We have this, we have the area, right? And we have side B as 17. And we have side A as 150. So we don't have our angle. So it's sine C, right? From here, guys, it's the usual mathematics, right? We have our, okay, I'm going to have to move my triangle for you guys. But we have our usual mathematics from here on out, where then first I start by simplifying the side. Let me move out my triangle. Okay. Okay, there we go. Right. So we start by substituting everything that we have, and we simplify it until we have our single unknown that we can see. And our unknown is angle C, right? So if you want, I'm very happy for you to swap these around so that you have your C on the left. Some of us are actually just that fussy, where we want to see the C or the unknown on the left, right? From here, guys, you simply divide by 5 to 50 so that you can only be left with sine of C, right? The purpose of this is for you to be able to cancel that so that you are only left with the sine of C. Okay? And when you are left with the sine of C, then this thing actually begins to look a lot like a basic trigonometric equation. Because when you simply write it, then you're going to write sine of C is equal to, I forgot to calculate this, right? This is a decimal, and it looks like a 0.87 or something to that degree, right? So when you find your sine of C, so in your calculator, you're going to key in sine to the power of -1 times in your bracket, you will say 5,000 times, it's 5,000 divided by 5,200. Or quite simply, you can have worked out your 5,000 divided by 5,250, which is 0.59. So in your calculator, you'll say sine to the power of -1 times, in your bracket, you have 0.95. Remember, guys, not to round off your answers until you have a final answer. So you'll use the 0.95238 dot, 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 as it is, right? And you come out with a C of 72.2 degrees. This is answer number 1. Then I'm going to take you back here, where I said to you, this, at this level, at this point, this is really beginning to look like a trigonometric equation. Then I thought to myself, sine is positive. So in which quadrant is sine positive? That's the question I asked. In which quadrant is sine positive? Sine is positive in the first and the second quadrant. So this is our answer for the first quadrant, right? In the first quadrant, angle C would be 72.2 degrees. Then in our second quadrant, our reduction formula in there is 180 degrees minus the reference angle. C that we've calculated here serves as a reference angle for our second quadrant, right? This is what you would be using to find the second angle in our second quadrant. So for your final answer, angle C is equal to 72.2 degrees or 107.8 degrees, right? And always, when you have the time and the opportunity, you do a back check. So you go back to your starting calculation and you key in half of 150 times 70 times the sine of 107.8, and the answer you should get is 5,000. Same if you say half of 150 times 70 times the sine of 72.2, the answer you should get is 5,000. And that is how you prove your two possible answers. And this is what I mean when I say to you guys, maths does not work in isolation. Just because we're doing the area rule, it does not mean we will not be applying any other principles. Sometimes you will find yourself applying the quotient functions, the Pythagorean identities, different rules at different times. Thanks, Bani. Different rules at different times across, because math is math falls across the board. So it's important with each section to grasp as much as you can, because it's definitely going to be relevant in other sections. Okay, guys, we have completed our area rule homework, and we are now going to move on to our sine rule homework questions. I'll take it so far that everyone is good under area rule. There are no questions, and I'm going to move on to our sine rule questions. Okay, so our sine rule questions, we had our question 1 that said, find all the unknown sides and angles in here. Literally all, right? So we're drawing our triangle. Let's draw a triangle. Our triangle says here we have a P, a Q, and an R. Okay, so our R is 3, little r is 3 centimeters. Angle R is 24 degrees. Angle Q is 64 degrees. So when it says find all unknown sides and angles, we're basically saying complete the triangle, right? Does everybody agree that the instruction means complete the triangle? The instruction is saying find all the missing answers so that we can see if we can be able to envision this triangle ourselves, right? The first part, I've literally just opened it up for you guys because it's just that easy. You need to, the first thing you are able to get very simply, very quickly is angle P. Angle P is literally because 180 is the sum of angles, right, in a triangle. Quite simply, quite straightforward, no complications whatsoever there. So your P will be equal to 180 minus 64 minus 24. And that gives us an angle P of 92 degrees. From here on out, we have all our angles and we have a side. Remember, the sine rule basically says that the relationship between angles and sides are the same for each angle and side and opposing side, the triangle. So we have one certain relationship. We have the R relationship. So we're going to use the R relationship as a basis to calculate the angle, the missing side for the other two angles, right? The sine rule, as it says, it'll say sine Q. So we're going to start by finding Q. We're going to start by finding side Q. Okay. So it says Q over sine Q is equal to R over sine R. If you were looking for the angle, you would say sine Q over Q is equal to sine R over R. Purely because I like to have the unknown at the top. When you have the unknown at the top on your left, then the unknown becomes the only remaining factor on your left, and so you're just solving for the right. Okay, so then from here you substitute your usual the information that you have available. You have Q as 64, you have small r as 3, and you have angle R as 24, and you are able to have Q on one side on its own. So you'll take this side and you'll multiply by sine 64 to get rid of the sine 64. What you do on the left, you do on the right, guys. And from there, you have that. Q looks something like that, right? Q looks like 3 sine 64 over sine 24. Calculator forward, bam, 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 and you get side Q as 6.6 centimeters. Relatively straightforward, I'd hope. 6.6 centimeters. So when we talk about the relationship, what I'm saying to you is if you go and you key in 3 over sine 24, right, you get an answer. And then you key in 6.6 over sine 64. This answer should be exactly the same. So the relationship, the ratio of the side to the angle is always the same, even if the numbers are not exactly the same. Okay, lastly, we're going to solve for side P, little p, right? Same formula, P over sine P is equal to R over sine R. So we substitute all the unknowns, and then what we do on the left, we do on the right. Multiply by the sine of 92, multiply by the sine of 92. Throw this into our calculator and we come out with P as 7.4 centimeters, right? Quick check, a sense check. The longer the side, the bigger the angle, the longer the side. Yes, there, I found my word. The bigger the angle, the longer the opposing side. Guys, my pen doesn't want to appear. Okay, the bigger the angle, the longer the side. So your biggest angle is 92 and your longest side is 7, and it is indeed across each other. Your smallest angle is 24 and your smallest side is 3, and indeed they are across each other. That is a quick sense check that you can do to check if you have calculated correctly, right? Then there's a part B to this. Part B says in triangle KLM, K is 43 degrees, M is 50 degrees, and small m is 1 centimeter. Right, so it's KLM, right? So small m is 1 centimeter. Angle K in here is 43 degrees. Angle M over there is 50 degrees, right? Guys, remember I had asked you guys, I said to you guys, would you be able to figure out, or my question to you was, with an area rule, do you know why the angle, with the sine rule, sorry, do you remember why the angle should not be included? And I said to you guys, from your homework, you'll be able to see why the area should not be included, the angle should not be included. And quite simply, we didn't get such an example. But if we get an example where I gave you the 7 here, and I gave you the 6 here, and I gave you the 24 over here, you would not be able to establish a relationship between the angle and side that allows you to be able to do this. That's really just the answer. Okay. But anyway, coming back to this question over here, we then work on saying, number one, the easiest thing to look for or to find. Okay. The easiest thing to find is your angle L. Angle L is equal to 180 minus 43 minus 50, which is equal to 87. Again, simple application of the sum of triangles. From here, what standing or what pure side angle relationship do we see? We are seeing an M relationship, right? So we are able to confidently say M over sine M. And that is the ratio or our measure that we will use for the rest of this, right? So to find L, we're looking for side L now. We're going to say L over sine L is equal to M over sine M. We follow the same methodology on substitution, and we find that L is equal to 1.3 centimeters, right? Same is true for our K. K over sine K is equal to M over sine M, and we substitute our values, and we come out with a K of 0.89 centimeters. Quick sense check again. Our longest side is 1.3 centimeters. Our longest angle is 87 centimeters. Bam. So we're correct. Our shortest side is 0.8 centimeters. So our shortest angle will be, so here we go. Our shortest side is 0.8 centimeters. So our shortest angle should be K, which is our smallest angle should be K, which is 43. And it is indeed our smallest angle. So we have done this correctly, ladies and gents. Simply, that is the sine rule, guys. At its simplest level, this is the sine rule. Okay. Then here, there was the second part of the sine rule, where now you're not drawing any triangles. I have given you a triangle, right? And I'm saying to you in this triangle, find the length of BC, right? So first you find BC to see where BC is sitting. BC is right there. So BC actually sits in this triangle over here. BC sits in triangle CD. So when you look at BC, the one problem that we have is we don't have any sides for, like, so we don't have, yes, we don't have any sides to work with. We don't have all the information that is required to work with the sine rule, right? We can have angle, two sides. We don't have an angle and two sides. We don't even have any sides. So then what you'd have to do in this case, or what you do is you work in your bigger triangle to see what your bigger triangle can get you that you can use in your smaller triangle. Okay, and what's hit me immediately is that we can use our bigger triangle because this is the point at which they intersect, guys. We can use our bigger triangle, which has more information, to find the length of BD. When we have the length of BD, we already have a side and two angles, and we are then able to apply our sine rule. Okay, so in our bigger triangle, we have a clear relationship between AB and angle D that we can use, right? So it's literally AB over sine of D is equal to, we are looking for BD, and BD is against A in the big triangle over sine of A, right? Quickly scan through, have a look, and we learn that we don't have angle A. But we do have the other two angles in the triangle So we can get angle A very easily by saying the sum of your angles in a triangle is 180, and we subtract what we have. We have a right angle over there, and we have a 15 plus 40 over here, which is a 55, right? And there we have that. We have our angle A as 35 degrees, okay? From here, we are then able to substitute 35 degrees in here. We are really able to substitute, let me say, everything that we need. So then we are able to calculate our BD, right? BD over sine A is equal to AP over sine D. Substitute what we need, then we're missing BD. And BD, ladies and gentlemen, comes out to 11.92 units, right? Now that we have BD, we have enough information in our smaller triangle, our BCD triangle. We have enough information to apply the sine rule in order to find the angle of BC. So we know that angle D and BC have a relationship, and angle D is 15. And we know that C and BD have a relationship where BD is equal to 11.2 units, 11.92 units, and side C and angle C is equal to 106. So we substitute quite simply, and we have BC as 3.2 centimeters. Hoping that makes sense to everybody. It's literally just that straightforward, right? So we've completed our sine rule answers, guys. And we have the cos rule here. We have homework on the cos rule. Somebody is asking, how did I get the sine of 35? Okay. Because here, let's go back here. We needed to first calculate this angle in here, angle A. Remember, we are working in triangle ABD, right? In triangle ABD, we have this 90-degree angle over here. Sure, okay, I'm going to unmess up everything, right? So it's clear. There we go. In triangle ABD, we have a 90-degree angle, and we have a 40-degree plus 15, which gets us a 55, right? So when we look for this angle, it is literally your sum of triangles, your sum of angles in a triangle. We do our math, and this is how we find ourselves with a 35. So now we use our relationships in the big triangle. And in the big triangle, BD goes with A. So that's how we use a sine of 35. Okay. I was made the assumption, or I'm under the impression that 40 is just this piece. But if this is Danielle. Danielle is saying to me, but isn't 40 the whole angle and not just this piece? In which case, I get what Danielle is saying, because then that changes this to 50. I actually made the assumption that 40 is just that other piece, but I hear you thinking on that, and I'm happy to work out a solution where we use that method of thinking, because what I see, Danielle, is it's actually probably Jerusha's asking also, because Jerusha did the same thing. We've run out of time. Oh, thank you guys for your questions. We've run out of time, but I'm happy to start with this question in our next lesson, because our next lesson is questions only. And I will start with this question by saying 40 degrees is the whole angle. I see exactly why you say that, guys. And I had used the whole of D as 55 degrees, but I see exactly why you said that. So what I'll do is I will work out the memo for you using 40 as that entire thing. And so using angle A as 50. And then we can see how that works. I see exactly why you did that. I think it's not a train smash, but I do see why you did that, guys. So I'll work that out for you to give you the principle in that regard, to give you the answer in that regard. and then we will move on to the cosine rules. Guys, I'm going to skip through my cosine questions because we're out of time. But what I do need, we'll start with the cosine questions next week. What I do need from you is over here. I've posted a link and I'm saying to you, please do prepare question 5 and 7 for Monday's class, because in Monday's class, we are going to be starting our revision of trigonometry. For the first 3 days of next week, we're really just doing trig questions. And I've said to you, if you've got any specific questions you'd like me to address, please send those to me, and you've got until Sunday 5 p.m. to send me those questions. So here I've posted the link. Please get hold of the slides to get the link, guys, and then please prepare question 5 and 7 for me for Monday. When we start on Monday, I'm going to be finishing the homework on the cosine rules, and we'll be continuing on to these questions. Monday to Wednesdays are days of questions on trigonometry before we move on to functions. Okay, guys, I've also attached a link for you guys, useful questions for like your past papers to practice with, hoping that could also be of some assistance to you. And yes, please, this is where you're going to send me the stuff. So contact me here so that I can give you my personal details on where you can send me your questions, etc. That's how we'll go about this. And from here, guys, I'm going to say to you, this is one of our last long weekends. Have a fantastic one, guys. Remember to contact us, Africa Teen Geeks, if you need information, if you've got feedback, if there's things you would like us to bring to you, things you'd like to see better. Here, this is where you find us. This is where you contact us. And we are always happy and glad to assist. Thank you for joining me, guys. Thank you for interacting with me, guys. I'll see you guys on Monday. Please prepare your homework. Have a great weekend. And let's do this again. Remember, take care of your hearts, take care of your peace of mind, and keep strong, guys. Keep strong. This is Miss Shabalala. See you guys on Monday. Bye.